Hi, my name is Krzysztof Tomaszewski and I'm a medical doctor specializing in the field of orthopedics and traumatology. In my everyday work, I treat patients with various musculoskeletal disorders like fractures, muscle, tendon, and ligament problems. Doctors, such as me, are called orthopedic surgeons because most of our patients need surgery to help them with their problems. I'm here to explain you a little bit about how does it happen that we can actually move. Movement is not only me walking or making gestures, but also talking, breathing, or your heart pumping blood. To move, we need to engage several systems of our body, including the musculoskeletal and nervous systems. Movement itself originates in the brain, and more specifically, in the brain's cortex. The cortex is the outer layer of the brain and has many grooves and folds and is grayish in color. Different movements engage different amounts of cortex. To say it easier, they use up different amounts of the cortex space. For example, movements of the hand, which are very complex, use up a large amount of the cortex, while movements in the arm, which you can see here or simply here, use up way less space of the cortex than the hand itself. So now we know that movement is initiated in the brain. The impulse, which will trigger the muscles to contract, originates in the brain, travels from the brain to the brain stem, where it changes sides. Why? Because the fibers, the nerve fibers at this level, crisscross. So, when you think about moving your right hand, it's the left hemisphere that is working. And vice versa, the right hemisphere controls the left side of our body. The signal that will trigger the muscles to contract travels from the brainstem to the spinal cord, and then from the spinal cord to one of the spinal nerves. From the spinal nerves, it moves, let's say, further along the line to peripheral nerves, which directly innervate muscles, tendons, ligaments, and bone. At the end of a peripheral nerve, there's a place called the neuromuscular junction, so the connection between a nerve and the muscle. When an electrical impulse reaches a neuromuscular junction, it changes from being electrical to chemical, and the chemicals released from the neuromuscular junction, which we can also call a synapse, trigger the muscles to contract. So now we know that in order to make a conscious movement, we have to think about it. The signal has to travel from the brain, through the brain stem, the spinal cord and the peripheral nerves, to the muscle. But what happens if you burn yourself? Well, you quickly move your hand away from the fire, right? But did you manage actually to think about that? So this was called a reflex. The one shown before has the sole purpose of protecting you from harm. But what is the difference between a reflex, which is an unconscious movement, from a conscious movement? So in a reflex, your heat receptors in the skin generate an electrical impulse which travels then to the spinal cord, but not to the brain, and directly from the spinal cord back to the muscles which contract and move your hand away from the fire. This shortens the way of the impulse from the muscle to the spinal cord and back again, well, making your move faster. What may seem like a simple task, like for example picking up an object, is actually a complex play of actors, many actors. Because how do you know how to choose the strength with which you pick up an object, not to drop it? Or how do you choose your grip strength, not to lose your grip on something? Those factors are determined in your cerebellum, a part of the brain which is located in the back of your skull. When the cerebellum is injured, for example, you may have problems in choosing how much strength you need to apply to pick up an egg, to neither drop it nor break it. Now, I would like to invite you not for a simple lesson, but rather for a series of experiments during which you will be able to learn how does it happen that you can actually move.